Hey, welcome. Today we're going to be performing some advanced level testing using a Labscope to take a look at a smart 4-wire ignition coil on this Lexus sitting here beside me. So we actually get to hooking up the Labscope on the car. Let's just quickly go through what it is that we're really going to be looking for on here. So with a smart ignition coil, we're going to feed them power and ground at all times and let the small module that's inside of there actually control our path to ground in order to turn it on and off. Now this is exactly why we're not able to do a resistance test across our primary windings like we can on a traditional 2-wire coil, because our module is in there and that module is actually controlling the path to ground. So we have power somehow getting into the coil, usually through a fuse. We'll put a fuse in here. And then generally speaking on V-style engines, really on any style engines, generally you're going to be sharing that ignition coil power with all of the other ignition coils that are on that vehicle. So on a V6, this powered fuse right here will most likely be powering all 6 of the ignition coils. Smart coils also are fed ground at all times. So we'll feed our ground wire in here. So power and ground at all times. This is probably running to a chassis ground of some kind, maybe under the hood into one of the fenders, one of the main ground legs right there being fed into our coil. So we're able to check for power and ground at the coil. Pretty straightforward. Probably don't need a Labscope to actually look at those. We will use a Labscope, but probably not needed. Where you're going to need your scope is to look at the other 2 wires. So we have a wire here, goes to our ECM. Because we have module-to-module communication here, we have an ECM telling the ignition control module that's inside of here to turn on and turn off. So what we're going to actually end up having is a digital square wave that's going to come up and look something like this on our Labscope. Now what we'll see is this square wave vary depending upon how long the ignition coil is being turned on for. If the coil is being turned on for a long time, we'll see the distances between the changes there in different manners. That's going to be our control. That's the module-to-module communication that we're going to be looking for with the Labscope. And then if we look at the 4th wire, we're going to talk about ignition coil feedback. Okay? Feedback is the response. The ignition coil is telling the ECM that it did its job. It created spark. It built up a magnetic field and did what it was supposed to. So this is what feedback is. Now on Lexus Toyota that we're going to be looking at today, a 4-wire coil is going to send a steady 5-volt reference whenever the key is turned on. That 5-volt reference is then dropped to ground when the ignition coil fires. It's like a short signal and then it comes back to 5 volts. Now, this 5-volt reference, this orange wire, is actually shared with the other 5 coils, 6 in total. So you will see 6 individual drops to ground on here. Okay, but the biggest thing that we need to make sure is we need to make sure that we're looking at our 5 volts. That's where our circuit's starting from, and our control modules inside of the coils are actually dropping that to ground or low reference on our vehicle. So that's what we're going to look for. We're going to look for our digital signal here, our digital signal for our control, and to make sure we have power and ground with the Labscope. So why don't we head over there and get it all hooked up. So we've already got the Labscope hooked up to the laptop, and we have 3 channels that we're going to be looking at today. Channel A, we're going to look at ignition coil primary voltage. That's our power and ground going into the coil. Channel B, we're going to look at that trigger signal that's coming from the ECM to the coil. And channel C, we're going to look at the feedback signal. That is the coil telling the computer it did what it was supposed to. So for channel A to look at our power and ground, what we're actually going to do is we're going to hook up each of the leads into the coil. Now you could hook up just one lead into the power side, hook the other one up to battery negative, but what I'm going to do is I'm going to take each lead and hook them into the positive and the negative of the ignition coil, which happens to be on this one, pins 1 and pin 4. So we'll go on one side and the other, and right now we shouldn't see anything because the key's not turned on. Go ahead and flip on the key and I should expect to see ignition system voltage. So with the key on now, you can see that we have ignition system voltage coming in right about that 12 volt mark on here. Now we'll hook up channel 2, or the red channel. That is going to be our ignition coil control. So that on here is going to be the pin right next to ground. So we're going to take our black lead and we're going to hook that up to battery negative. We're going to take our red lead and we're going to hook it up to our brown wire on here. And this is going to give us our control. And then lastly, we're going to take our green wire, our green channel here, channel 3, and we're going to hook this into feedback. Now, like I said, key on, engine off on feedback, we should see a 5-volt reference on here that the coil module itself is going to drop to ground. So if we plug that in, there we go. We're going to scale up our channels here. We'll throw them all at the, so channel A and B are at 20 volts. We'll bring channel C up to 10 volts because that's supposed to be that 5-volt signal. There we go, we're right at the 5-volt mark. So we've already verified that our feedback signal is able to get to the coil. We have power and ground to the coil. Now we're going to look for that feedback on here. We're going to increase our time. Let's go 500 milliseconds, or a half a second per division, giving us 5 seconds total on the screen. Let's put our air box back in place so we can run this thing with the mass airflow so it's back to normal operation. And then we should be ready to go and get it started up. As with any time you're using a Labscope, guys, make sure your leads are out of the way of the cooling fan or any moving parts under the hood. We should be set to go. Let's fire this thing up and take a look at what we've got. All right, so our scope is capturing a relatively long amount of time. And we'll just go ahead and pause this. There we go. All right, so now with our capture pause, we can go ahead and analyze this. We can get zoomed in and take a look at what we've got because we have a ton of information on the screen. So let's go ahead and just zoom in on a section here. And we'll get this guy out of the way. And our red channel again is our control. So every time we get a spike here, we're actually looking at that coil being told to turn on, create our magnetic field, and create that spark. So let's just take a look at a couple cycles here. We'll go like this. There we go. Now you can see the red channel goes from roughly low reference-ish, around 0, up to about the 5-volt mark, 4.5-volt mark. That is the ECM, the engine control module, telling the module inside of the coil to turn on. The green channel here is, again, like I said, it's starting at the 5-volt mark and is dropping down to a little under a volt, roughly. We're at about a volt right here, a little under a volt. That's going to be our low reference. That is the feedback coming out of the ignition coil. Okay, so the ECM tells the coil to turn on, and actually, if we zoom in really close here, you can see the coil turns on. The module takes just a tiny amount of time inside of the ignition coil to tell or to ground the path for the feedback circuit, telling the PCM that it's turning on. And if you look at our voltage here, you can actually see our voltage in the battery actually drop down, or the voltage going to the coil actually drop down. This is our primary voltage. You're seeing that drop down because we're drawing a lot of current on that line as our coil is currently being turned on. So our voltage drops down, we shut the signal off from the ECM, and we induce our voltage onto our secondary windings, and we create that spark across there. Now, if you're missing your control circuit from the ECM, if you don't have that red trace, you're going to want to make sure that, for one, the ECM hasn't disabled it for some reason. Because it's possible, especially with a smart coil, a module coil, and today's computers, it's possible that the ECM could have recognized a problem in the circuit and it could actually turn off this coil. So it may no longer send a signal off to the coil if it knows that there's a problem. Same thing with our feedback. If our feedback here is at 0 volts, well, then we might have an open circuit, or maybe our feedback signal is down. What we also need to look at with feedback is we want to see all of our other coils. So if we just take a quick look here, you can see our other coils in operation here, okay? So they're doing what they're supposed to. Each coil creates a feedback for their respective position on the engine. They all tie on the same line. So if that line is down at 0 volts, but you only have a code for one cylinder, chances are it's somewhere where that splice occurs to the ignition coil itself, or you have a bad new ignition coil, okay? Now you could get into some current testing and that kind of stuff with the coils, but by hooking into positive and negative of our ignition coil and watching that voltage drop a little bit while the coil's charging, it tells me that something is actually occurring here. It's telling me that we probably have something happening. A current test might be easier if we're testing under the intake manifold, but in this case, just to check all 4 wires, this is going to be the quickest way to do it and the most accurate way to do it using a Labscope. If you're running into issues, look at a wiring diagram and determine what exactly is supposed to be happening. Feedback circuit coming in at 5 volts being dropped to ground. The control circuit is at low reference being taken up to roughly 5 volts. And our voltage should be around battery voltage to make all this work. If that's all there, it's most likely an ignition coil type of problem, okay? And don't forget that in the event of a failure or a trouble code, the coil could be turned off or disabled from working. It's also possible to have the the fuel injector shut off as well in that event, especially on a modern computer. So this again has just been a way to test a module coil, a 4-wire coil, using a Labscope. So thank you very much for watching. We'll see you in the next one. Happy wrenching, everyone.